Shri students. So today we are here with lecture second on sets, class 11th. So we're going to discuss what are the types of sets with relevant examples to understand what are the types of the sets. So the first type of set is known as empty set. This is the first type of set, students. Now, what is a empty set? Let us try to define a set in set builder form as set A, set of all, set A is set of all y such that y plus 2 is equal to 0. Y plus 2 is equal to 0. Y plus 2 is equal to 0. And y is a irrational number. Okay. Now, student, I'm asking you, in this set, can you think of any element? On one side, it's told y plus 2 is equal to 0. On the other side, its definition also says y is an irrational number. So, can you think of any value for y which satisfy both these conditions? Yes, please answer. Hello? Hello, Ishma. Can you tell me any value for y which satisfy both these conditions? One is y plus 2 is equal to 0 and other is y is an irrational number. No. The answer is no. Why? Because from here I get y is equal to minus 2. But minus 2 is not an irrational number. Minus 2 isn't irrational number. So that means there is no element which fulfills this criteria. So I can say that set A is equal to 5, or I can simply write the braces. So from this I get an idea for empty set, which is also known as null set or void set. So students, if I want to define this set, how can I define these sets? Can I just say that it is a set which doesn't have any element? Okay, so I can say a null set or a void set is a set which doesn't contain any element, right? This is the definition I'm writing here. See that? A set which doesn't contain any element is known as empty set, call it null set or void set. So student, here I can give more examples also. For example, if you see set of all elements, B is a set of all x such that x is a student who's studying in 10th class and 11th class. So this is also an example of a null set, because it's not possible that a student is studying in 10 as well as 11th class simultaneously. So I can say set B is a null set. All right. So now students, we can even think of another example, that let's say B is a set of all x such that xk minus 2 is equal to 0 x squared minus 2 is equal to 0 and x is a rational number. So by the first condition, we come to know that x squared is equal to 2. Obviously, x will be equal to plus minus root 2. Now, Ishma, root 2 is a rational number or irrational number?
Irrational.
Okay. Can you please tell me what is a irrational number? Any number
Which cannot be expressed in the form p by q, where q is not equal to 0.
and p and q are integers. Or you can say irrational number is a number which is not repeating. It's not repeating. There's no pattern in this. At the same time, it is not ending also. It is not terminating also. It keeps moving. Like maybe 70.51, 511, 5111. So 51 is not repeating. Rather 51 becomes 511, then it becomes 5111. It keeps growing. This is an irrational number. By the first condition, we know that x is an irrational number, but it is told that x is a rational number. So there's no value for x which satisfies this. Hence we can say set B is a null set, call it void set, or you can call it empty sets. So this is done. Now students, we go further defining finite and infinite sets. Let's talk about a set student A. Let's say A has elements. If I'm writing in roster form 1, 2, 3, 4, 5. I can also say, let's say I define a set B. B is, maybe you can say all, maybe you can say this is, you might say B is a set of all x such that x is a alphabet in word principle. So you can talk about another set C. Maybe C is a set of, you might say, all x such that x is all the x's any male in a particular city. So if you say students, set A has 5 elements. Set B has, you say, the letters in the word principle. So if you leave the letters which are repeating, so remaining would be a finite number of letters this set would be having. Though this set looks infinite, but actually all the male members in a particular city must be some finite number which can be calculated, which would be there in the records of the city's mayor in the population register. So all these 3 sets are actually the example of finite sets. Yes, Ishma, come on, give me an example of another finite set and then we'll discuss its definition. Yes, say that.
D is equal to x such that
You should not say
x
equal to.
belongs.
You should define D is a set of all. D is a set of all
X
x such that
x belongs to n
okay, x is a natural number and
x is greater than equal to 1,
then or
less
equal
than
to
greater than
less than or
or
equal
equal to 20.
20, let's say 7. All right. So it has 7 elements, right? So I can write this set in the roster form as 1, 2, 3, 4, 5, 6, 7 in the roster form. So these are all the definitions of finite sets. Let's see the definition. A set which is empty or consists of a definite number of elements is known as finite. Otherwise, the set is infinite. Now, students, it's worthwhile to see that a null set is also a finite set, because if I say it has 0 member, so 0 can be counted. 0 is finite. So, null set is also a definite set. It's a finite set. Now, students, also want to talk about one more thing, that how we represent the number of elements of a set. Number of elements, number of members, or number of objects of a set. So the notation we use to uh, define number of elements of a set is, we'll write n set A. So this means the number of elements of set A. So what it will be? It will be equal to 5. So Ishma, similarly, what will be the value for n of D? Can you tell me? The set which is stated by you?
7.
Correct. N of D would be 7. So what would be n of C? You don't know. But definitely it will be some number, maybe like 3 lakhs or whatever it is, right? No, it's not an infinite set. It's a finite set, because male members in a particular city, even if it is in the whole world, also, the male members will not be infinite. Am I right? So even if it is in the whole world, this set will be a finite or a definite set. All right. This is how we represent the number of members or objects of a set. Now let's talk about some infinite sets. We're going to talk about some infinite sets. So the definition I've already rolled down. A set which has uncountable number of elements is known as infinite set. Now it's worthwhile to see, can we write infinite sets in roster form? As I had mentioned in lecture 1, that there's a difficulty in expressing the infinite sets in roster form. Sometimes we can do it, sometimes it is impossible. So let's see the cases. Students, in case we want to say that we want to express a set of all natural numbers, all natural numbers. Now, Ishma, can we express all natural numbers set in roster form, which is an infinite set? Please answer.
No.
We can, but with some techniques, but we cannot express all the infinite sets in roster form. So how do we do it? We take advantage of 3 dots. So let's say A is a set of all Z such that Z belongs to N. That's all. This is in set builder form. But we can as well represent this set in the roster form. Like it would be, we will write few elements of that set. Natural number, the first known natural number is 1, 2, 3. You may write 3 elements, you may write 4 elements, put a comma and put 3 dots, just 3 dots, close the braces. This is the way we can represent infinite set in roster form. Similarly, Ishma, if you say express all integers in the roster form, Ishma, do you remember what is the notation for integers? That notation for integers is n. What is the notation for integers? I guess it is z.
Z.
Right. So In the set builder form, I might give a name of set of all integers as, let's say, b. So I'll state that b is a set of all x such that x belongs to z. Well, that means x is an integer. In case of roster form, I can as well express is at again three dots, 1, 2, 3 towards minus infinity or just infinity, comma, minus 2, minus 1, 0, 1, 2. You can put 3 also, no problem. Put 3 dots, close the braces. This is in a good way. You have expressed an infinite set in set builder as well as in the roster form. All right, but there are few sets. Students, can you think of any infinite set which cannot be expressed in roster form? See, students, in order to answer this question, note important technique when we express infinite set in roster form. We have written 4 elements. Well, these 4 elements do tell us that how the next elements come after the last element. Okay, we just added 1, 1, 1. So it's all natural numbers, right? So anyone can guess what will be the next numbers. Similarly, it's minus 1, minus 2. Anyone will be able to guess it will be minus 3, minus 4, 0, 1, 2, 3, 4, right? But then if you say, what about set of all real numbers? It is not just possible to write all real numbers in some pattern. We no matter how hard we try, we cannot talk about any pattern. We cannot talk about any repeated way in which we can write all the real numbers. Why? Because real numbers are rational. Real numbers are also irrational numbers. So how can we think of a set in which all the real numbers will come? So it's not really possible to express this kind of set. Maybe some other sets also you can think of in the roster form, which are infinite sets. Yes, students. So all infinite sets cannot be described in roster form, but it would be wrong to say that any infinite set cannot be described in a roster form. Some can be. For example, the set of real numbers, then it's because the elements of this set do not follow any particular pattern. All right. Now, students, we are going to discuss the last type of sets. Well, this is equal sets. So, few important points, students. Now, let's say I define uh, set A in the roster form as, let's say, A, B, C, D, E. Like I have set B. I define set B as a set of all x such that x is any of the five first alphabets in English. So obviously it means the first 5 alphabets are A, B, C, D, E. Now these two sets exactly have the same number of elements. So I can say A is this, and from the definition, if I write B in the roster form, I know that B is A, B, C, D, E. Though I may write this in any order, it doesn't really matter. Maybe B, C, B, A, E, it doesn't really matter. Or to the extent that I can even repeat some elements also, doesn't matter. C, C, B, B, A, E, D. Right, ultimately, am I missing any number? A, B, C, D, E. A, B, all the elements are there. So in this case, when both the sets have same elements, I can say they are equal sets. When they're equal sets, I can write A is equal to B. As simple as that. Now, as I've repeated the elements here, but essentially this set and this set and this set are identically same. So I can always say number of elements of A, number of elements of B, you know, they're same. So if I want to define equal sets, how will I define? I can define two sets are said to be equal if the if the elements in A are same as elements in B, but saying that only will not suffice. Why? Because let's say A has elements A, B, C, D, E, and let's say B has elements A, B, C, D, E, F, G. So if I say all the elements in A are also the elements in B, this is correct. But the reverse is not correct. What? All the elements of B are not the elements of A. So if you want to see like this, I must say all the elements of A must be the elements of B and vice versa. Means all the elements of B must be the elements of A. Either you say like this, or there's a better way of defining equal sets. Tell me, Ishma.
Two sets A and B are said to be equal if they have exactly the same elements and we write A is equal to B. Otherwise, the sets are said to be unequal and we write A is not equal to B.
Very good. So we have seen some deviations that the number of elements here, you know, that A, B, C, D, E, I can change the order, I can repeat the elements, still A is equal to B, right? This is also the reason generally that we don't repeat the elements. All right. Yes, a set does not change if one or more elements of the sets are repeated. For example, the sets A 1 2 3 and B is 2 2 1 3 3 are equal sets. And why? What's the reason? The reason is since the elements of A and B are there in each, that's a reason. So we can say that these sets are equal. Yes, students. Now we can spend maybe 5 more minutes on doing these sums. So this is exercise 1.2. Ishma, please read the first sum.
Which of the following are examples of the null set? First, set of odd natural numbers divisible by 2.
Yes. Is it null set? Set of odd natural numbers divisible by 2. Do you think this is possible of having an odd number which is divisible by 2? Exactly. Yes, Amitoj? Is it possible to have an odd number which is divisible by 2?
No,
No,
sir.
only even numbers are divisible by 2. So this is the first one
Null
is a
set.
null set. There cannot be any member in this. There cannot be any element in this. Yes, Ishma, read all and keep commenting whether they are null sets or not. Keep discussing.
Set of even prime numbers.
Set of even prime numbers. Yes, tell me.
No, this is not a null set.
Set of even, this is not a null set because 2 is a prime number. So 2 is even also, right? So just 2, just one member, just one member it will have. So it is not a null set. Next, third one. Third one, students. Please read.
X is such that
No,
X
you should
is
say,
a
no. You should not define this set like this. You should not define it. A set of all X. Basis means set of all. Set of all X such that, colon, X is a natural number and X is less than 5 and X is greater than 7. Oh, how can a number be less than 5 and greater than 7? Is it possible?
no, sir.
Not possible. It's a null set. What about fourth one? Yes, sir, Jinder? A set of all Y such that Y is a point common to any two parallel lines. Come on, two parallel lines do not have any common point. The common point exists only in intersecting lines, right? So we've done the first sum. Okay, please read the second sum also.
Which of the following sets are finite or infinite? First, the set of months of a year. Finite.
Is it finite or infinite?
Finite.
Sets. Okay. Yes. What about this? Second one is infinite. Third one?
Finite.
Finite because it has dots, but after the dots there are finite numbers. How many elements are there in the third set? Deep? No, in third set they are not infinite, beta. It's ending at 100 elements. What about four? Set of all positive is greater than 100, infinite. Set of all
Infinite.
less than 99. Yes, Ishma? Is
Right.
it finite or infinite?
Finite.
Finite. All right. So state whether each of the following set is finite or infinite. Set of lines which are parallel to x-axis, infinite. Set of letters in English alphabet, yes. Set of letters in English alphabet.
Finite.
Correct.
Finite.
So what is the number?
26.
Third one, the set of numbers which are multiple of 5. Such a
Infinite.
infinite. But if he says set of numbers which are factors of 5, then it would have been a
Finite.
finite set. Okay. Let's do the fourth sum. In which of the following state whether A is equal to B or not? Yes, tell me. Remember, if a member is repeated, it doesn't matter. So first one, A, B, C, D. Then A, B, C.
True. First is true.
True. Though the order is different, but it have same elements. What about the second one? 4, 8, 12, 16.
False.
4, 8.
False.
It's false. Third one. Well, you have to understand this. It says set of all x such that x is a positive even integer and x is less than or equal to 10. So all the even integers which are less than or equal to 10 are mentioned. So they are
True.
Equal.
And the fourth one, set of all, Ishma, how will you say this? I want you to practice how to give a statement of set in set builder
Of
form.
all
X
set of all x such that x is a multiple of 10.
10. And what about B? No, 15 is not multiple of 10. So A is not equal to B. Very good. So from the sets given below, select equal sets. So select any set which is equal and then we finish this lecture. Which set is equal? Just see. Equal sets.
E and G.
See 1, 2, 3, 4. Here 1, 2, 3, 4. D and B are equal. Then
P and G.
E and
B
G.
and E and E. Where is E? E is minus 1, 1. E and G are also equal. 2, 4, 8, 12. So 2, 4, 8, 12. No, it's not there.
A and C.
A and C, 2, 4, 8,
No,
12.
no,
They are not equal because 2 is replaced by 12. So fine. So B is equal to D, and then we can say what? E is equal to G.
G.
Thank you very much. All right, students, wait for the third lecture. We'll discuss subsets and then intersection and all of the properties of sets, which are very, very important from competition point of view. So share with your friends. Have a nice time. Take care.